And that's exactly what I had to do. I went and bought a new sampler. This one's a little bit different than the other one. This has the ability to actually record multiple samples into it, and the quality is a little bit better. A few seconds ago, you didn't see any of this set up. Unfortunately, I got so frustrated after I blew my other unit up and couldn't find anything cheaper than this $34 sampler that was close by. I did not record building this or putting any of this together. And if I did record it, which I thought I did, I cannot find the video. I'll leave the link down in the bottom, but this is just a DIY sampling kit, and briefly go over what we've got here. We have output to speakers, input for power, and then these two sets of wires, the blue and yellow is corresponding to the blue and yellow out of the loop detector harness, and that is actually triggering the play button. You can see right here it actually has a set of contacts that correspond directly to the push buttons over here. The only thing I didn't like about it is it only has one ground, which makes sense. Electrically, that's okay, but I couldn't easily find a way to actually tie into that other ground. So what I did was I needed two functions. So as opposed to playing the same thing over and over, because again, this is an interactive display, there's no purpose for this sampler other than the fact that it engages people to come and touch the loop detector and touch the loop. So, and as opposed to playing the same thing over and over and then leaving instructions to have them forward through the sounds, what I did was I actually trigger the play button, and then I trigger the forward button from these two wires right here. And the way that I have that set up is the blue and yellow is just from relay 1, normally open and common, and then I have relay 2 set to pulse on the presence being undetected. So the way that that works is let's say we change the inductance with our single gang box, our double gang box, and then the play button will be triggered, and that stays just like that. In that state, I think the play button is just a single shot. It doesn't continue to play over and over. We'll see it here in a minute. It plays whatever sample is currently in the loop, and then when the inductance goes back to, if you will, a normal state, relay 2 triggers the forward button. So we'll see that here in a second. Once I put this thing together, I had to change. I soldered this after the talk that I did, and there's a link for the talk right here. So I didn't have to have instructions set up there. I went ahead and wired this to the push button over here so it would cycle through the loops. But the next time that I do it, I'll probably actually leave instructions that will allow people to record their own samples. So if they want to record their own voice, they just hit record, it'll store it in memory, and then they come and they change the inductance of the loop, and then it plays exactly what they just had. And when I do that, I'll probably disable the forward button. But you didn't get to see any of the video of this being put together, so let's just briefly talk about this for a second. So basically, this is just a 1x6 piece of cedar, and I drilled holes corresponding to where I wanted zip ties to go through. And it's a little bit easier to see back here in the back. So I just did a hole on both sides of the device that I was trying to secure. And on this one, I did 2 sets of holes because I was wanting to actually run through the factory holes on here. I took this sampler back apart for 2 reasons. One, like I said, to actually solder that onto the forward button, and then I had, because I was in a hurry when I was building this, I had just mounted the sampler directly to the wood without having any isolation between the contacts and the wood. Now, we know that wood is not as conductive as copper or aluminum or gold or silver, but it does have the ability to absorb water, and because this is an interactive display, You could have people have their drinks around there and they could accidentally spill something. If they spill something close to this, that water's going to stay on there for a while until it dries out. So what I did is I took some of these little cushions that I got from my Altronics SMP3 power supply, and I have that now separating from the board. So if by chance there is some liquid that gets on there, it should be okay. It should be separated from that. So I'll go ahead and put these zip ties back on there like it was, and this should complete the display, and then we'll talk about what I've got going on here. So this is basically how the display looked when I went out and talked, with the exception of just a couple of different things. So let's review this real quick. We have the EMX loop detector right here. It's EMX as the brand name. The model is DTEC. We have the terminal block here, and it looks like it's complicated, but it's really not. So we have the normally open and common coming out of the loop detector, and that's what actually will complete the circuit for us depending upon what we're wanting to do. And then I have these jumpers, and their corresponding colors to normally open and common. I'm not sure which is which, but they jump each pair right here. So blues here, and then blues here, and then yellows here, and yellows here. And that just allows me to have inputs and outputs. And what I mean by having an input to an output is, for instance, I can take this connection right here, plug this into call box or to a B panel, an access panel, and actually be electrically the same as the relay that's actually coming out of here. So as opposed to using this relay to close the circuit, I can use a relay from another device to close the circuit. And that's why I put so many of these jumpers. But at the same time, because they're all electrically the same, it triggers whatever device I have hooked up to it. If I want to have a call box trigger the sampler, and I want the sampler to be triggered from the loop detector, I can do that just by hooking up to one of these blue and yellows. And now that I look at it, logically, it would probably make more sense to have this thing backwards, because we're going to always have these connected to the same spot. So you might want to have easy access to this side right here. So probably flipping this around would be a good idea. So let's take a look at the harness again one more time. So we got black and white to power, and we already saw how we hooked that up. That just goes to this little connector right here. And so far that's been good. I mentioned earlier that I may have wanted to use a socket for this to actually put it in vertically, and I think that that's a great idea if I was just going to use this setup for my bench, because then I wouldn't worry about the high voltage being exposed. In case you wonder what I mean by the high voltage being exposed, this is similar to what the socket looks like. Now the footprint is probably right around the same. It's a little bit wider, but obviously this is just a relay that's covering it. And if you put this loop detector in a similar size socket, the loop detector itself will actually cover a lot of these conductors, and very well could cover the high voltage. Even if the loop detector's covering it, you don't want to have an interactive display with high voltage exposed, even slightly exposed. You never know who's going to be touching the display, and you don't want the liability of somebody getting shocked or hurt, much less you don't want it on your conscience for anybody to get hurt. So that's one of the reasons why I was saying you don't want to do that, or you want to have this protected some way, shape, or form if you do put it on a socket. But the thing I like about putting it on the socket is you can mount it. You can mount it right here, and then you could easily unplug and plug a loop detector in to test it. And for a bench, that would be great. For an interactive display, I'm going to stick with what I had put in text in the video before, that I think I'm going to stick with this, because although you can't see the LED flash and you can't see these functions right here that easily, you don't have to worry about the loop detector walking off on you, somebody actually taking the loop detector, because it's obviously not easy to pull out. Also, on your bench, if you wanted to test another loop detector, you could just very well pull the back of this off and then plug your loop detector in there, and then you don't have to worry about it triggering anything, because it's still a pretty good distance away from the loop. And I think the only thing that I added afterwards were these two conductors, and I'm going to make these a little bit longer and put solder on these. But what these were for was to actually be able to probe the circuit. Now, I don't think I'll be talking about probing the circuit, so for demonstration purposes this won't be needed, but on my bench I will be probing the circuit with an oscilloscope and or voltmeter and or frequency counter, because I need to be able to analyze what the loop detector is putting out with a known good loop. And this is the actual other part of this display slash test rig, is this inductive loop that I've made. Now, I had a link at the beginning to the DIY loop that I made out of a Gatorade can, but this is how I originally would make these. I would just take a 3-inch, 4-inch piece of PVC and drill a couple holes in it, run wire around it, and then you could see that it's shiny. What I would do is I'd squirt a bunch of silicone on it and then take a paintbrush and then paint it on and make it smooth. And it did two things. One, it kept the wires from moving, and it also added an extra layer of protection to the wire, because I would just throw this in the back of my service vehicle and it would get banged around. So then I have the output of that, which is coming out the back there. You can see the red wires, and then they just come over here. Okay, so again, this would be nice to have this flipped around, this terminal block here, because there may be another case where I want to add a bigger amount of inductance by putting in like this mega loop that I made here, and there's a video for that as well too. So I may want to change the load that's actually on the loop detector to see how it reacts, and I would do that depending upon what the loop that's hooked up to the loop detector in the field is doing. So if I'm testing a loop detector, I want to actually try to simulate the loop that's actually out in the field that it's testing. And then the next part is the sampler, and this is just completely interactive. This is not something that comes with the loop detector, and it's not something that comes in a typical setup. I'm going to finish making these two connectors so that we can use this to probe the output of the loop detector, and then we'll see how everything works. Because this is being hooked up to the loop input, I'm going to make it brown and gray to correspond with the colors that's coming out of the harness. I've made these about 3/4 inch long, so now I'm going to add some solder into it, so when I do probe it or hook my leads to it, over time it won't get frayed. I'm going to use these spade connectors on the other end of these two jumper wires. So here's the final set of jumper wires, and this will allow me to get my probes on here really well and give me enough length so it's not going to be in the way. One thing you may want to do if you're going to set up these types of terminal block is actually, as opposed to use these spade connectors, use a ring terminal, and that way you can back the screw all the way out and then put the ring terminal in there and screw it all the way down. That way, if you are unscrewing and screwing these terminal connectors in and out, you don't have to worry about those coming out. Like you can see exactly what happened here. You could just see how this one's coming out. If you put ring terminals on there, unscrew the screw all the way out, put a ring terminal in there and then screw it on there. You don't have to worry about it coming out unless you back the screw all the way out. And this ring kind of prevents you from doing that. Well, actually, this ring in combination with the washer that holds these down. I'm going to do these spade connectors. I think this will be just fine. I got a feeling I won't be taking these in and out all that much. Now that I've got it soldered, I think this wire is going to last a long time. That looks pretty good. And that'll give me just the ability to take some multimeter probes or an oscilloscope probe and then clamp on there. But I've got enough room that I can actually take that, take my oscilloscope probe, put that on there, and then if for any other reason, which if I wanted to check frequency or current, I could actually plug another probe on there without having any problems. I decided to go ahead and just mount this little speaker on here. I was using this big speaker box that I made for guitar preamplifier. Just wanted it to be loud enough to where people could hear it, but if anything, I'll make put a connection on here to where I can change those out, but I'm not going to be using this display all that much for these purposes. I'll just be using it to test inductive loops and loop detectors. So drilled a couple holes, and then if my theory is correct, should be able to crisscross these and hold this on there. Alright, so this is what the final display looks like. Everything from here on over is the interactive display part. The coil and loop detector and this harness to a certain extent are all the permanent things that you would need in order to test a loop detector with a known good load. The terminal strip may not be necessary. You don't necessarily need to jumper everything together, but it would be nice to have the ability to actually connect multiple probes directly to the output of the loop detector, so you can measure different things: frequency, current, voltage, and possibly duty cycle. So that's how it is set up, and for display, it would just be laying on a table, and I would have a little car that anyone could actually pull over the loop and trigger the sampler, and it would be heard through the speaker. So
you mean dollars? Ooh, you make me so scared. Access granted.
So the speaker's not all that loud, but I think it's good enough for my purposes. And this will, with a set of instructions, give the people the ability to actually record their own words and then go through it and trigger it. And you could make something like this for either the bench or out in the field. And if you need to test a loop detector, you just pull the harness off, provided that it is the same voltage, plug it in there, and then you could actually trigger it by putting a load across the coil and see how the loop detector works. Now, in order to do that, you would need to also be testing certain things, which is why I have this little jumper, and I'll get to that in the next video. But this is pretty much how the display looks. And if you're interested in the talk that I did here in Dallas about access control, you can click the link right here and check that out. It's about an hour long, and it goes over just some basic access control and some vulnerabilities of the equipment that we have. Please do me a favor, subscribe to my channel and give me a thumbs up if you like it, and leave comments below.
Don't forget to like and subscribe.
The one input hooked up from the coil, and then I've got the output, which is this wire right here, hooked up to the play button on this little sampler. And what I wanted to do was take a look at the voltage over time and how it reacts when this coil has